This is practice test number 4, and here we are working on problem number 7. And the problem reads, a study was conducted on the amount of money spent by customers for lunch at a local restaurant. The average cost of lunch, the X bar, was $34.55 for 25 customers with a standard deviation of $10.15. Assuming a normal distribution, construct a 95% confidence interval estimate for the average cost of lunch for all customers, which is the population mean mu. So that's what we're looking for, 95% confidence interval for the population mean. Now we're given the formula here at the top of the page that we need to use to construct this 95% confidence interval. And the information given in the problem is shown here, that the X bar is 34.55. The S in our formula is $10.50. And the N, which is the sample size, is given to us as 25 customers. And we need to find the T value to use in this formula. It's going to come from the T table that was given out in class. You can find it also in another video in this practice test. We first calculate the degrees of freedom, which is n minus 1, which is going to be 24. And then when we look in the table, we're going to go down to look at the DF column on the far left. We're going to go down to 24 degrees of freedom and then move over to the right until you come to the 95% confidence column, and you should get this T value of 2.064. And then we will plug in the values into the formula. The X bar 35.55 minus the T of 2.064 times the S, which is 10.50, divided by the square root of the N, which is 25. And the square root of the N, 25, is going to be 5. When we calculate this quantity right here, we're going to end up with 4.3344. And we will subtract that from the 34.55. And when you round off to the hundredths place, because we're dealing with money, you should get 30.22. Over on the right-hand side, this quantity right here is going to be the same, 4.3344. The only difference over here, we added on to the sample mean, and we should end up with 38.88 as your upper limit for the confidence estimate, for the interval estimate. So this is the 95% confidence estimate, and we can say that 95% of the time our population mean will be between these two values.